Welcome, Hornets. In this group of lessons, we're going to be taking a look at what the AP board is expecting you to be able to do and how to use a implicit differentiation. Now, the first question that we're going to look at is to show what a derivative should be. Now, you'll notice they're giving you the function x squared minus 2xy plus 3y squared equaling 2. And their goal is to ask you to show that dy dx is equal to y minus x over 3y minus x. Now you might ask, why are they giving us the answer? Well, that's because of the questions in B, C, D, and potentially E. Now, they don't want to just give you the ability to demonstrate, but they want you to be able to then show how to use it. So it's important for them to make sure that you have the correct derivative, dy dx, in the later problems that you're going to need. However, they do want you to show how to do it and make sure that you can. So that's our first step today, is to demonstrate and show that our derivative is going to be y minus x over 3y minus x. So now, to begin with, we're going to do our implicit differentiation the way we would normally do it. We know we have explicit with the x, so we have a 2x. And then we're going to use our product rule, making sure that we put a 2 followed by y, and then minus 2x dy dx. Now, when I did this product rule, I did the x times y, and I distributed the negative 2. Go through the 2 steps in your head or on paper, and you will find life easier. Just above, I'll show you what I did. I did the derivative of the x, so I have dx dx times y, which turns out to be 1y, and then I have plus x dy dx. I then distributed the negative 2. Now, in the next piece, this is our explicit. It has no x attached to it, so we're working with our chain rule. You just have to see that y as the last piece inside. You get 6y dy dx equals 0. Now, believe it or not, the most common error is that constant at the end. It's supposed to be the easiest piece to do, yet people often forget it. So take a look after you're done and just check your work. It's to your advantage. Now, once you're done, you'll notice everything has a 2. Factor the 2 out and divide it. Just get rid of it right at the beginning. Divide everything by 2. It will help and clean up your work. This would also include any potential factors that we might have. Oops, that's supposed to be a 3. I got distracted by my emails. Don't forget your dy dx. That's what we're solving for, and it still equals 0. Now, in the next step, we're going to move everything that doesn't have a dy dx. That means that I'm going to go ahead and I'm going to move my y. It will become a positive. I move my x, and it changes to a negative. I factor out the dy dx, and I'm going to move it to the front. And I'm going to rewrite this so that the negative x follows. Notice now I can divide both sides by 3y minus x, divided by 3y minus x, and I now have that dy dx is equal to y minus x divided by 3y minus x. This is what they want you to show. Let's just review our steps again. We start with our original equation and we do implicit differentiation, just like we did starting yesterday. In fact, starting on Monday. So we go actually, I guess starting on Tuesday. Sorry about that. So we have our 2 for 2x. We work with our product rule. We distribute the negative 2. We do the implicit differentiation for 3y squared. We make sure a constant goes to 0. We get rid of a common GCF. It can be any factor that is common. Please do not get rid of x's. All right, that's important. So if they had an x that was in common to all terms, keep it. We're talking about integers, okay? Remove integers if you can. Then move the non-dy dx's to the other side, factor out dy dx, divide, and simplify. Now always check and make sure sometimes the terms are flipped around. All you need to do is factor out a negative and then multiply it through. Factoring the negative causes a flip, multiplying it to the denominator causes a flip, and vice versa. All right, thank you very much, Hornets. I hope this helped. Please do the next problem, and you will be able to identify the process, I hope, that will help you.